Today we're going to talk about dividing radicals. When we divide radicals, we just break up the numbers individually as much as we can, and then cancel things out. So I'm going to break up this radical 20 here, so I'm going to leave 3. I'm going to break up the 20 into 5 and 4. Usually you break them down as much as possible, but I'm going to stop with this radical 4 here, and you'll see why in a second. This is divided by 2, radical 4. And now since everything's multiplied, I can just cancel things out. Radical 4 divided by radical 4 makes a 1, so that goes away. And I'm left with 3 radical 5 over 2. And that's it. Let's do another one. Number 2 here. Little different because we have variables in here now, but you do the same thing. I'm going to break up this 15 into a 5 and a 3. The x will go by itself and the y will go by itself. Over 3 times 10 can be a 5 and a 2. And then I have the x here. And then the y's, since I have more than one y, I'm going to break that into y squared and a y. And the reason it's a square is because the square will undo this radical here, so the y will just come out. So the 5 here and the 5 here are going to cancel because those make a 1. And I've got 2 x's here that divide and make a 1. And the y's here will make a 1 as well. And remember, this is going to come out of the square root. So I'm left with square root of 3 on the top over 3y and then a radical 2 on the inside as well. And we can square that one as well so we can see that. So again, the 5's canceled, the x canceled, and the y's here canceled. This y squared is a perfect square, so that can come out and join the 3 that's also on the outside already. So I have 3y, radical 2 left, and then a radical 3 on top. And that's it. Let's do another one. Number 3. We got radical 625 x to the 4th, y to the 5th, over radical 75 x to the 9th, and y to the 10th. And again, we're just going to break this down as much as possible. Preferably, you use perfect squares if possible. So 625 has a perfect square of 25. So 625 is just 25 and 25. X to the 4th can be broken into x squared and x squared. And y to the 5th will be y squared, and y. All of that over 75 can be broken into 25 and 3. X to the 9th, so that's going to give me x squared, that's 4, 6, 8, and 1 more makes 9. And then I've got 10 y's. So we have a y squared, that's 2, 4. I'm out of room here. I'm going to run into my next problem. That's alright. 2, 4, 6, 8, and 10. Alright. See if you can see all that. Zoom out a little bit. There we go. Oh, not quite. There. Alright, now we're just going to see what can cancel. These 25s go away. X squareds. Got a few of those that can go away. I'm left with this here. This one here. I like to box what I have left so I don't lose track. I've got these x's here. And then I've got 2 y squares that can go away. I'm left with a y here and all these y squares. Now we simplify. Square root of 25 is just 5 with a radical y left on top. Over x squared and x squared, those are perfect squares, so those can both come outside. And then we've got all these y squares. There's 1, 2, and 3. So I've got 3 of those. And then I have a radical 3 and a radical x left on the inside. Now let's simplify one more time. Gives me 5 radical y over, let's scoop this paper up, there we go, over x times x is x squared, and I've got 3y's here, y cubed, with a 3x left on the inside. And that would be my final answer. Alright, let's do one last one, number 4 here, that we kind of ran out of room on, so we're going to have to write down here. Okay, we have 15x squared, radical 128, y to the 9th, over 10y, radical 72x to the 5th. So again, we're going to break this up as much as possible. So I have 15x squared. Let me break up this radical. 128 is just 64 and 2. And then, of course, y to the 9th. So there's 2, 4, 6, 8, and 9. All of that is going to be over 10y. Break up the 72 into 36 and 2. There's 36 and 2, and then x to the 5th. So 2, 4, 5. Alright, now let's simplify. Square root 2, square root 2, those can go away. I don't have any y squares that can cancel with anything on the bottom, and I don't have any x's that can cancel with anything at the top. So now we're just going to simplify. Square root of 64 is 8, so I'll have 15x squared on the outside, times this 8 that comes out. And I've got a y here, 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 and here. So that's 4 of them. And then I'm left with this y on the inside. All of that over 10y. Again, 36, that's a perfect square, so that comes out. So times 6, and then this x and this x makes 2 x's, so x squared, and then this x left on the inside. And now I just keep simplifying. 15 times 8 is 120. I get 120. There we go. X squared, y to the 4th, radical y, over 10 times 6 is 60, y, with an x squared here, radical x. Now, 120 divided by 60 is 2. X squared over x squared, those will go away. And then I have y to the 4th over y. If you remember your rules for exponents, if I have y to the 4th up here and a y to the 1 power on the bottom, that leaves me y cubed on top, times radical y over radical x. And that is your final answer. And that's how you divide radicals.